Hello and welcome. It is time once again to try to fix something in today on the workbench. Another PS5 Blu-ray edition that is a no power, I believe. Yeah, that's what the little note on the side says. It is quite dirty, let me say. There's dirt all down in there. So, yeah, she's going to need a good cleaning. But right now she doesn't work at all. I think I have, power is plugged in. We get no reaction to power or eject, so that's rather dead. Okay, let's get the covers off and see how serious this issue is. All right, the side plate is off, and like I said, very dirty. Can you see that down there on the fan? Yeah, pretty dirty, but we're sealed. Factory sealed. So that's always a good sign. Yep, quite fuzzy. Quite fuzzy. This thing may have had overheating issues. I'm wondering now. Alright, I have one of my spare 400 DR supplies in there. I don't think I've got anything shorting anywhere. Okay, let's see what she does. I forgot to put the fan in there. Well, we won't leave it on that long. I just want to see if it comes back to life. I do have HDMI cable plugged in. It may have to have a port also. That's it's coming up. Yeah, I was just that port is split a little bit. It's hard to see there, but it's had a rough life as well. So I may just go ahead and change out that port while I'm in here. But yeah, she's going to come back to life. We just need to figure out what's up with this supply. Yeah, she's coming on. Because you know me, I don't want to just swap out the power supply. I want to fix this supply. So yeah, we'll get this inside on the workbench and so we'll see if we can figure out what's going on with it. Yeah, it looks good. Well, here we are at the workbench, and I have saved you the trouble of watching me open these things up. So it's already opened up. I have not discharged anything. Because I don't want to handle it yet. What I really want to do right now is just kind of confirm our problem and try it with a load. We were getting 8 point something volts out there in the garage with no load. I'm kind of curious what it does when it does have a load to drive, when it is forced to deliver some current. So let me put this in here. Okay, now I'll turn this on. 8.8, and let me turn. All right, that's still no load. No load. Let's turn this on. Yeah. All right. That's 1 amp. She's delivering 1 amp of current right now into my DC load. Bring this up a little. 2, 3, 4. Well, it's still staying up. What if I turn the load off? I'm hearing a vibration, a noise. I'm not sure where it's coming from. If it's coming from my variable AC transformer or the supply itself. But that's kind of surprising. It doesn't just fall flat out on its face when it gets hit with some load. That's 4 amps still of current draw right now. And she's holding 8.8. So that's odd. I'll tell you what, one thing I did want to check though, what is our PFC voltage right now? Are we getting 400 volts? Are we getting something less? See if I can carefully get in here and check this. 395, okay. So I would say our power factor correction circuit is working just fine. Our regulator part of this thing is not. And of course this is regulated by feedback, from via an opto-oscillator from the cold side over here back to the other side, the hot side on this side. The side that's tied to the AC transformer, the side to the AC is the hot side. And the part that's isolated from the AC line is the cold side. So we seem to have an issue with that feedback circuit. But our power factor corrector is good. All right, let me turn this off. Something's definitely making a humming sound there. Not a normal humming sound. I'm not sure what's happening with that. Okay, let me disconnect our DC load. Don't think we're going to need it right now. I'll go ahead and discharge these capacitors. Yeah, she still had 380 or so volts there, so yeah. Very dangerous. Okay. I'll go across. These capacitors in parallel, so it really shouldn't matter. Yep. We're pretty well discharged now. So now we're safe to handle. Anything look obvious under here? I mean, this is not going to be, you know, what I normally run into where you have a short, you know, a really obvious short that kills it, and, you know, it stands out pretty well because you can read it with your meter. This is going to be something a little more strange, I have a feeling. Let me look this board over, and I'll bring you back if I find anything interesting. All right, where are we on this power supply? Well, as you can see, I have two of them sitting here. I did a lot of diode checks on this board, comparing against the notes I had. I couldn't find anything wrong. Everything looks fine as far as diode checks, you know, here on these optical isolators, on these ICs over here. Seems normal. So I decided to get out another supply. This is with the check mark is my good one for comparison. This is a known good one. And I've been making comparisons between the two. And I was trying a new approach. Someone in my comments mentioned this, and I can't remember who it was. I apologize, but about how you could, you know, basically inject 12 volts on these output terminals to test your feedback circuitry. And if I can, well, that's what I've been doing. You can see I got 12 volts coming out of both channels of that supply into these. Let me show you over here. What I'm doing, this is not the exact circuit, but it's an example of how this circuit works. On the output, I am injecting 12 volts here. There's no other power applied to the supply. It's totally dead. There's no AC into it. I'm just applying 12 volts to the output, and then checking the current or the voltage drop at each one of these little resistors and across this. This is a LM, was it TL431 or TL432, depending on which one they decide to use. It's a precision reference. So a good way of checking that and the optical isolator is basically if you can inject 12 volts there and just see what you get. And I also checked what kind of resistance I get at the other side of the optical oscillator. If I measure from collector to emitter in resistance mode of my meter, I'm getting like 36 to 40 k ohms, something like that, on both these power supplies. With 12 volts sitting here, you know, whatever current pushes through this, it produces a certain amount of light, which comes out over here and is turning on the biasing on the base of this phototransistor. And I'm getting about the same resistance across there with both these supplies. So what I'm saying is it should be working. Everything seems absolutely fine as far as with this output feedback regulation stage. This stuff right in here seems to be fine. So at this point, I'm afraid I am at the point of just changing out the DAP53 because, yeah, it looks like the most likely suspect. Although looking at diode checks, I don't really see anything. Don't really see a problem. But that's my next step, though. right, our DAP-053 has been replaced. We are ready to check this, I think. Make sure I have my load connected right polarity. It does not like it if you reverse it. And let's turn on the AC over here and see what happens. No, 8.7. We are still low voltage. Another DAP-53 wrongly accused. Okay, what's going on with this? All right, still no luck. Still making a lot more comparisons, looking a little closer. Sometimes I like to check resistance readings to ground on the several pins, make comparisons. This is the working one, and this is the broken one. I have a new theory here. My theory is that the voltage regulation is fine on this board. And what may be happening is it's shutting down and starting back up, very rapidly, which would in turn make the voltage go up, down, up, down, up, down. So what I'm going to do, I think, is try to disable the shutdown circuitry, which I believe is going to be this one right here. This is for the voltage feedback. This is how the the voltage from this side that's being generated, the 12 volts, you get a signal back to the other side. You see the dot for pin 1, so that would be the anode of the diode, the LED inside this package. And so this is another signal going back that way from the cold side over here to the hot side. So I have a feeling what I'm going to do, I think, is lift one pin on this opto-isolator. And if that makes the supply run, then we know that that's what's happening. I don't want to leave it that way, but we're going to see if lifting this disables the shutdown circuitry and then lets it run. That's what I'm going to try to do right now. All right, I think I'm ready to test. All I've done is lifted pin 1 of IC52 there, that opto-isolator on the bottom. If I can get a pointer. Right here, I lifted pin 1 to effectively disable that shutdown. And we're going to see what happens. If I can get my focus to work. We're going to see what happens. And I want to pay close attention, though, to what the voltage does, because I don't want it to shoot up too high. Load is on. I'll keep my hand on the on-off switch over here. Let's see what happens. No, 8.7. We're still low. That's not it. Still too low. All right. There is another opto-isolator. I think I lifted the wrong one. This one here is another shutdown. A shutdown initiated from this side, the hot side, to the cold side. And I have lifted pin 1, 2, 3, 4 to disable that one. That's this opto-isolator right here. And now, when I apply power, we put out 12 volts. So yeah, lifted the wrong one. So we still have a problem. And I think I've seen this before. I've had this exact problem. I want to say there's some little MOSFETs involved in driving this opto-isolator. It's some type of overvoltage detection for the AC voltage coming in, which is driven, I think, from this MOSFET right over here, I think. All right, let's take a look under the microscope at exactly what our issue is, I believe. I can get everything set up. All right, here's where I lifted this opto-isolator, right here. And where it's driven from is right over here. And let's see, this is ground. I gotta make sure it's in the shot. Here's ground. And here would be the control gate of it. And if I measure between this other leg, which is the signal going off to shut something down, I suppose. Let's see. No, this would be ground. Which one of these is the gate? No, this is the gate. I'm sorry. This would be the output driving the MOSFET. So between here and here, 1K ohm between the gate and ground. 1K ohm. All right. Now let me look at the other one I have here, the working one. Where is it? Right in there. Go to those same points between the gate and ground. Yeah, we're up over a meg ohm and climbing. So I'm pretty sure that our W4R MOSFET has failed. And it didn't fail completely. It's like breaking down. I've had this issue before, but in the past it caused a complete shutdown. I don't believe it's ever caused the, odd voltage where it's intermittently trying to shut down. But I do have some of these on hand. That's a 2N7002. Let's get that changed out. Well, our 2N7002 has been replaced. There it is there. Kind of hard to focus on it. And we are ready to test something here. I think I've got my load connected. It's turned on. I reconnected to the legs of those opto oscillators. Let's see what happens. If I can get my camera to focus. And there we are. So our problem the whole time was just that MOSFET. Yeah, that DAP53 was perfectly fine. Well, okay, let's get this back together and we'll try it out there in the chassis. Well, this PS5 is fully reassembled now. Our repaired supply is installed. I did go ahead and change out the HDMI port on this console. The original one was just, it was working fine, but it had started, spreading a little bit, gapping. The shell, the outer shell had kind of started spreading apart, so it wasn't going to last too much longer. So I went ahead and changed that out, and we are ready to test this thing out. Lights. Oh, monitor's locking. There it goes. Beautiful sight. She does have some scratches around the HDMI port. Not a whole lot I can do about that. But there we go. She is fully restored. Well, hope you enjoyed that one. Thought it was somewhat interesting and entertaining. If you did, please give me a thumbs up, and I will see you in the very next repair. So long for now.